Welcome to Dampere Chemtech. In this video, I will be talking about very important aspects in laboratory reports and scientific data reporting. Now, in this, I'll be talking about conventions in rounding off decimal places and significant figures. Now, in the lab or in your experiments, you are required to generate some values, and these values are sometimes called primary data or values, which you are required to do some mathematical calculations to arrive at given results, and these results must be reported correctly. Sometimes they are required to report in a given significant figure or decimal places. Even in your theoretical work in class, the examiner might require you to report a given answer in a specified decimal places or significant figures. So if you are not acquainted with the act or the practice of rounding off decimal places and significant figures, even though the steps are right in your calculation, you might be wrong at your answer. The same thing, even though in your experiment or your practical, the values are correct, the process of doing the mathematical calculation, you might report the answer wrongly, and as a result, even though the laboratory values are correct, your answer is wrong. Then you get it wrong. So it's very, very important that students are acquainted with these conventions. Now let's talk about rounding off before we talk about decimal places and significant figures. Now let me start with rounding off now. Rounding off in common uses approximation. This is the practice of rounding a number to the nearest whole number, decimal places, and significant figures. Before going into details, you should understand that numbers are counted, read, or pronounced from left to the right. For example, 543.543. Here note that after the decimal point, you are expected to consider every digit as units. Hence, you pronounce them one after the other. 543.543. Let's at this point also talk about certainty and uncertainty of numbers. In every measurement, the last digit is uncertain. It could be less than that value by 1 or greater than that value by 1, which is plus or minus 1 to the last value. So the last value is always uncertain. Now that is the case for non-exact measurements or non-exact numbers. For exact numbers and exact measurements, this does not apply. Now, for instance, a dozen is made up of 12 items. So, if we say a dozen of pens, what we mean is 12 pens. So, that 12 as a measurement is an exact number. So, uncertainty of measurement does not apply. Another example of exact number or measurement is the Avogadro's number of particles. Now, amount of atoms in a mole is the Avogadro's number of atoms. All laboratory measurements are non-exact measurements, or you can call it inexact measurements. So the numbers are associated with some uncertainty, and that the last digit is always uncertain, which I have earlier explained. For instance, you are given an object and you use a weighing balance to take the measurements, and the measurement happens to be 207 grams. Now, by this principle of uncertainty in measurement, we have said the last digit is always uncertain. That measurement could be 206 grams or 208 grams. Not only that, that applies, as we have said, to every measurement. Now, for instance, if another measurement of volume was 104 milliliter, it could be 303 milliliter or 105 milliliters. Or a measurement was taken of a distance and is 0.35 meters. That measurement could also be 0.34 or 0.36 meters. So you see, it's all the last digit could have been +1 or -1. Now let's consider rounding off conventions. Number 1, if the digit to be dropped is less than 5, the rule says the preceding digit is left unchanged as the last digit. For example, if we have a number or a measurement that reads 8.14 grams, I want to round off this measurement to two significant figures or one decimal place. So we can round it off to 8.1 grams. Because the digit to be dropped here is 4, which is less than 5, and the preceding digit is 1. For the fact that the digit to be dropped is less than 5, you drop it and the preceding digit is left unchanged. Hence, we have the correct answer to be 8.1 grams. Let's look at the second convention. If the digit to be dropped is 5, the preceding digit is set to the nearest even number. Now, for example, if we have a measurement that is 8.145 grams and we want to round it up to 2 decimal places or 3 significant figures, what we can do here, for the fact that the number to be dropped is exactly 5 and the preceding number is an even number, what we do, you are expected to just drop the number 5, which is the number to be dropped, and the preceding number, which is an even number 4 here, is left unchanged. So we can round off 8.145 grams to 8.14 grams. Now, but if the preceding number is an odd number, practice would no longer be the same. For instance, a measurement that reads 8.135 grams can be rounded to 8.14 grams. Now, the number to be dropped is 5, while the preceding number is 3, which in this case is an odd number. So, you will not just drop the number 5, but you will drop the number 5 and increase the preceding number by 1. So, it's now read or reported 8.14 grams. Now, rule number 3. If the digit to be dropped is greater than 5, the preceding digit is increased by 1 as the last digit. Now, what does this imply? That if the digit you are to drop is greater than 5, what you are expected to do is that you drop that digit and you increase that preceding digit by 1, irrespective of the digit, whether it is an even or odd digit. Now, for instance, we have a measurement 8.146 gram. We can round it off to 8.15 because here the digit to be dropped is 6, and 6 is greater than 5. Hence, what we do, we drop that digit and we increase the preceding digit, which is 4, by 1. So, this will now be rounded off to 8.15. Now, let's look at decimal places. Decimal places are counted as the number of digits after the decimal point. For example, 0.0123 is 4 decimal places. Now, after the decimal point, the number of digits counting from left to the right are 4. Hence, this number is in 4 decimal places. Now, another example, 0.000 is 3 decimal places, because after the decimal points we have 3 digits. Even though they are zeros, they are digits. So this is 3 decimal places. While 321 is 0 decimal place, because there is no decimal point in this last number, which is 321. For the fact that there is no decimal point in it, it is 0 decimal place. We can now look into significant figures. Now, significant figures, you must be acquainted with the following rules. Now, rule number 1, non-zero digits are significant. Example, 567.345 is in 6 significant figures. This number has 6 significant figures because all the numbers are non-zero numbers. Let's look at rule number 2. Rule number 2 is zeros are sometimes significant and sometimes not. Number one, under this rule, zeros between non-zero digits are significant. For example, 2005, 2025. This is four significant figures because zero there is between non-zero digits, hence the zero is significant. Now another example, 25.021 has five significant figures because the zero here is also between non-zero digits, hence it is significant. Now zeros at the end of a number containing decimal point are significant. Example, 25.0 is three significant figures. Why? Because this number has decimal points and the zero happens to be at the end of the number. Hence, this number is three significant figure. The zero is significant. Under rule number 2, I, zeros at the end of a number that does not contain decimal points are significant, except is reported in standard form. For example, 2000, 2000 is four significant figures. But if it's expressed in standard form, it will now be 2 times 10 raised to 3. Here is just one significant figure. So if a number that does not contain decimal points and the zeros happens to be at the end of that number, those zeros are significant, except it is reported in standard form. We can now consider IV. Zeros at the beginning of a number are not significant. Example, if you have a number like 0.061, this number has just two non-zero digits and the zeros are at the beginning of this number, hence all the zeros are non-significant, but only the non-zero digits are significant, hence this number is two significant figures. Now that we are done with significant figures, I want to touch or treat reporting calculated numbers. Now, in the laboratory, as I have said earlier, some values are gotten directly from the experiments and some other values are gotten by some mathematical operations. Now, how can you report these calculated values are very important. In scientific reporting, only the certain digit and one uncertain digit is reported as the result of a mathematical operation. I will explain this more when we move to the next step. Under reporting calculated numbers, we have two rules. We have addition and or subtraction operation. Number 2, we have multiplication and or division operation. Now, addition and or subtraction operation, you report the results in the same number of decimal places as the number with the fewest decimal places in the calculation. Now, for example, we have three numbers here we are adding together. Now, among these numbers, we have the first one is 20.42 grams. That is in two decimal places. The second one is 1.322 grams. That is three decimal places. The last number is 83.1 gram. That is one decimal place. Now, among these numbers, 83.1 is the number with the lowest decimal place. Now, the rule says report your results in the same number of decimal places as the number with the fewest decimal places in the calculation. Hence, our results are reported in one decimal place. The summation of the three numbers here gives 104, which is 104.842 grams. Now, the summation is in three decimal places. We have to adjust it to match the results. We have to adjust the result to match the value with the least decimal places. Now, in this case, this our sum, the summation, has three uncertain digits. Three uncertain digits. Digits 8, 4, and 2 are all uncertain digits. And the rule also says we can report only the certain digits and one uncertain digit. So, what we will do is we shall drop the two uncertain digits and retain only one uncertain digit. By this, we can now round off the result, which we have three decimal places, to be reported in one decimal place. So we'll now drop 2 and 4 and retain 8, and that's our value, our result can be reported as 104.8 grams. Now you see that the result is in one decimal place because the individual numbers that were summed to arrive at the result has a number with the least decimal place, which is 1. And so our result is also presented in one decimal place. Under addition and subtraction is decimal places we consider. Now we can now proceed to multiplication and division operations. For multiplication and division operations, you report the results in the same number of significant figures as in the number with the fewest significant figures. Now, here I'm trying to work out the area of a rectangle. Now, the breadth and length. Now, example, 6.221 cm times 5.2 cm. That multiplication operation will result into a value 32.3492 cm square. Now, in this, our result here after the multiplication operation, you see, is in here. As you take note of the significant figures, here all the digits are non-zero digits, hence all of them are significant. So we can now count the number of significant figures in this result. 1, 2, 3, 4, 5, 6. They are 6 numbers. Being that all of them are significant, we have 6 significant figures. Now, these 6 significant figures, you can see from the result, from the working, from the values in which this multiplication operation was carried out. We need to look at the one with the least significant figures. Now, looking at the values, 5.2 cm is the one with the least significant figure. Now, 6.221 has 4 significant figures, while 5.2 cm has 2 significant figures. So, here we understand that we have the number with the least significant figure to be 2 significant figures. I mean, the number with the fewest significant figures is 2 here. Hence, the result is expected to be presented in 2 significant figures. Now, our result is in already 6 significant figures. We are expected to round it off to 2 significant figures. If we do the rounding off to 2 significant figures, we'll now have our results as 32 cm square. 32 cm square. That is the correct answer. Now, don't ever forget that for addition and subtraction operations, you consider decimal places. But for multiplication and division operations, you consider significant figures.